You might want it on these ones. But also, definitely going it's just filters through all this temperature as we type.
That we're writing, right? So, for example, if I put one over here, there's only one item with this because there's 10,000 items. But it will automatically filter everything, but it
It's
does
just
feel a little bit like not smooth because as I'm typing this and as this list grows, it will indeed need more time to calculate stuff. For example, if I were to put another zero over here and I were to continue typing this, it's still smooth, but if I were to add more and more, right, this would get pretty tough. It can even break, as you can see. It just broke my app. Let me go back. But yeah, calculations do get expensive, especially when you to your memory. So the thing is, whenever it's loading a calculation, you want to show the user some sort of immediate update to notify them that something is happening, like for example, showing a loading spinner whilst you do the calculations. So you're basically prioritizing an update to your UI, which is the loading spinner, while putting the update of showing the new filtered items to the background. Now, how you do that is with the use transition hook. So what do we do in this case? Well, we'll come over here at the top and we'll call the use transition hook like this. And it will give us back two things. One is the transition pending? And the other one is, well, this is a function to start the transition. Now the is pending is what we want for our UI, because I'll come over here and I'll just say, okay, is the transition pending? Because if it is, I want to show a little p tag that says loading. So it's a little loading screen for us. Now, how will it know what transition is in progress? Well, we'll wrap around the expensive filtering over here and use the start transition and then just pass all of this information as a callback function. So we'll do this, we'll save it, and now the use transition hook will know what is the expensive calculation, and when it's done, it will set the is pending to false. So we'll see. As I'm typing, you'll start seeing the loading screen. So I'll say item, and you saw that for a second, it prioritized showing the loading like text before showing the actual filtered items. Because if I wasn't doing this and I wasn't using the use transition hook, it would just show me whenever it was ready. But in this case, it'll show a loading screen and it'll continuously show whenever it requires time to load stuff, which at the end it doesn't require that much. But in the first time you type item, it does require because it's looking through everything, right? So this is the basic example of why you might want to use the use transition hook. I use it a good amount. It keeps interactions with the users pretty smooth. It avoids UI freezing during like expensive updates, and it overall just improves the user experience because it shows loading states when usually previously I couldn't show loading states, or at least I didn't used to, because I obviously use loading states when I'm fetching data from an API. But with something like this, where I'm filtering data and doing everything on my code, I don't really have alternatives other than this, or I didn't used to. So I do think it's great, especially for situations like filtering, which is the most common use case I've seen. Now, if you're a beginner and you're watching this, I would make the easiest. I would say that the easiest analogy to understand the use transition hook is that it allows you to put less attention to the important work, which is in this case filtering the items because it takes longer, and put immediate attention to an easier thing to just show to the user so that users get immediately happy with what they're seeing. They're seeing something happening, they're seeing the loading screen, while the complex and hard thing is being done in the background. So I personally think it's especially useful for improving performance and improving user experience in large or complex apps. Now let's go over the use deferred value hook. This hook is extremely similar to the previous hook we just explained, the use transition hook, but it has some minor differences that completely change the use case of it. We're going to be using the same code example as before because I feel like it will help explain the difference between them, but in its core, the use deferred value hook it helps you delay updating a value until the app has time to process it. It is specifically useful for smoothing performance when the current value is updated too frequently, like when you're typing on an input to try to search and filter for a list, and you're typing too fast, which makes the state update a lot, meaning that it might cause issues with the performance of how your states are or how your components are updating. So the main characteristics of this hook is that it will allow React to prioritize rendering the urgent updates, like the user typing, but it would also delay less critical updates to avoid blocking the main thread of your application. And the best part is that it doesn't require any manual logic like using the use transition hook where you had to specify where in your app you wanted to start the transition. So in this case, it is very similar to something like a debounce that you might be used to if you're, I don't know, writing search queries that searches or fetches data from an API based on what someone is typing on an input, but it has some differences because in this case, we're not delaying the execution of the filtering or the API request. What we're doing is just deferring the value update to reduce the cost of rendering that information. So how exactly would we implement it here to make something similar to what we did with the use transition hook? Well, what we would do is we would say use deferred value over here in the top, and then we obviously have right here an input and we have a query variable, right? It represents what we're searching here. So we'll put 2, 3, this goes to the query state. And then we have this items list is the same one as before, and then we filter the list. Now, what I want to do is when we do this calculation here, right? The items calculation, the filtering, I want to, instead of using this query variable here to basically check to see if this item is included in this 10,000 sized list, I want to create a deferred version of this query. I'll say deferred query, and I'll set it equal to the use deferred value hook and pass in the query. I'll defer this value exactly for the reason of having smoother performance, because now if I use this defer query over here, it should already be working. Now we obviously don't see it directly. We can also get the loading spinner like we had before, because now we have two pieces of information. We have the query and we have the deferred query. And we know that the loading screen will only be the case, it's only loading the data if the query is not equal to that deferred version of the query, the one that is waiting to be done with the calculation until it's set. So we can just ask if query is not equal to deferred query, then we can show a loading screen. So we'll say a p tag and then loading. And again, this is crucial for when you're dealing with complex operations that would benefit from reducing the cost of rendering. It's mostly with like something like typing fast, like I'm trying to do right here, but it will actually not make you run into issues where it's taking a lot of time to filter through that list. Now, you might still be wondering, how is this different from the use transition hook? Well, it differs in what it does, when to use, and how it works. Because what it does is it defers a value from propagating immediately, when the use transition hook, on the other hand, defers the state to update or render some sort of task. And then on the part of when to use, you would probably use the use defer hook whenever you're working with frequently changing values, like this input. And it just happens that the example I used for the use transition also involved typing on inputs, but the use transition is mostly used when you specifically need to render heavy UI or updating a specific state. And finally, the way you use it is different, because this will automatically delay the value. When the use transition hook, you need to specifically wrap whatever you're trying to calculate around with the start transition function. So this is one of the most useful ones, I think, from the new hooks that we have so far, together with the use transition hook. I think there are things that a lot of people probably didn't realize would really benefit them and their projects. And React is really handing down the whole part of improving performance, because that's definitely something that will help React in the long run. Now, let's talk about the use sync external store hook that was recently introduced in React 18. Now, to explain this hook, I made this example component over here, which is a very simple component that just fetches data from the Pokemon API and displays the list of Pokemons. Now, we're going to change this hook to be using the useSync external store, but in order to do that, I want to just explain a little bit about what this hook is. Well, the useSync external store hook is designed to let components be able to subscribe to external stores, like for example, global state libraries or custom state managers, in a way that's very safe for concurrent rendering. This was introduced in React 18 to solve issues with concurrent rendering when you're dealing with situations like this. It ensures that your component stays in sync with whatever external state you need, and it avoids issues like tearing, which is basically when your rendering is inconsistent during updates. Now, the use sync external store hook looks like this. You'll create a variable called state, and we're not currently implementing on this example. I just want to show how the hook actually looks like. But we'll create a variable called state and set it equal to the use sync external store. And then this hook, you need to pass technically two things, but you can also optionally add a third thing. The three things you need to add is, first, a subscribe function. So we'll have to create that, which will register a listener for any external state changes. Then you will also pass in a get snapshot function, which will also create, which its main purpose is to return the current state of a store. And then there's also the optional thing that you can pass here, which is a function called get server snapshot, which this is specifically meant for when you want to provide a snapshot for server-side rendering. So in this example that we have over here, what we want to do is create a custom store that will fetch the Pokemon data from the API. It will update the state and notify all subscribers of this store when the data is ready. This means that you can create a store for some sort of API data and have a lot of components subscribe to this store so that they can be synchronized with how the data is updating. So how would we do it in this case? Well, I'll create another file over here inside of our use sync external store folder, and I'll call it the Pokemon store.js. Inside of here, I'm going to create the things that I need for this, like the subscribe and the get snapshot. Since I'm not using server-side rendering for this, I'll remove that. But we'll create those and we'll import it on this file. So the first thing we want to have a store for something like this logic of fetching Pokemons is creating a state variable. So we'll create a state, and it will be an object, and we'll have one piece of information, one property called Pokemons, and it will be an array. And we'll call this the initial state. Then we'll have some listeners, which will also be a list because it will be the list of our subscribers. Then we're going to have a function over here that is going to fetch the data and update the state. So inside of here, we're going to create and export a fetch Pokemon's function, which will be async. And we already have that logic, so I'll just paste it over here. I'll grab this over here, paste it. Now, one thing you might have noticed, oh, actually, I'll delete this. One thing you might have noticed is that we don't have a set Pokemon's state like we have over here. So instead of saying set Pokemon's, what we can do after we get the data is we can set the state variable that we have at the top equal to Pokemon's, and then set the data dot results inside of here, because data dot results is how we get the information from the Pokemon API. And then we can use that listeners array to loop through each of the listeners, so every single component that is subscribed to this, and we'll call a function called listener, like this. And then we'll go through the listeners array, which contains all of the components that are subscribed to this store, and we'll grab each listener. React will automatically set this callback function to have this listener function, which we can then call. So React does this for us. And then this will notify all of the subscribers. And then down here, we're going to just create a variable called the get state. It's a getter for this state, the state of our store. And we'll also have to create the subscribe function. So I'll say subscribe is equal to listener, because this will be passed by the useSync external store hook as well. And inside of here, we'll grab the listeners array. So if I want to subscribe a component to this, I'll just grab that array and push the listener that we're connecting through the hook. And then when we finish this, we also want to clean this up and return back function where I said listeners is equal to listeners.filter, and we'll just filter out if the listener is already there. So I'll say L is not equal to listener. This is just some logic to keep it. I know it's a bit confusing, I recognize that, but this is a very common pattern that you might see when creating a store like this, and it makes it very easy because now we can remove all of this logic from here directly, and in this sync external store, we can grab the subscribe function from that file. We can also get the get state function, or the function, the getter that we created from this file as well. Now we'll delete the state. We don't even need a state anymore because this will handle everything for us. Inside of this, we'll get back a state object, which we know has the Pokemons inside of it. And we do need to fetch the Pokemons. So we have created this fetch Pokemons function. So I'll just call it, actually I'll call it over here, the fetch Pokemons function. And we'll just have a normal use effect that will call it on the first render. So we'll just call it over here, and I'll put the dependency list as empty. And you'll see that this does work and it handles everything for us. Now the great thing about this is that any other component that needs to access this data now can just use the useSync external store hook and handle all of this automatically without having to write all of this logic every single time. Now this is great. I haven't personally used it that much since it got released, but it's great because it keeps state management separate from component logic. It also ensures that your component is always in sync with the store, even if you're in the situation of concurrent rendering mode. And I think it's a pretty simple structure when you get used to it. Now, one thing you might be questioning yourself is, why didn't we just do all of this logic inside of a context and then use the useContext hook to grab that data? Well, there's a couple of things that differ between doing that and using the useSync external store. I think it mainly differs on purpose, performance, and reactivity. So talking about the purpose, the useSync external store, like I said, The purpose of it is just syncing React components with some sort of external store. Whilst the use context hook and creating a context, its main purpose is something else. It's sharing state and data across a component tree. Now, you can indeed do something similar using either of those. But where it comes very different is the performance, because with the useSync external store, it's specifically optimized for React concurrent rendering and it will avoid unnecessary re-renders. Whilst the use context, every single component that is consuming the context will re-render when the context value will change, which in some cases might cause performance issues. Now, the last thing is reactivity, because the useSync external store components only update when the store changes, whilst in the useContext hook, the context triggers updates for all of its consumers, even if some of them don't need change, which goes hand to hand with what I just said about performance. And I feel like in situations where you're just sharing static or infrequently changing data across some components, maybe some global states like the theme of your website, or if the user is authenticated or not, maybe use a global context. But in this case over here, if you're syncing with global state libraries like Redux, or you're using external state sources, something like the sync external store might be good for you. Thank you so much everyone for watching this video. This was a lot of work and I would really appreciate if you guys could leave a like and turn the notification bell on, because that would tell YouTube that you want to watch more videos like mine. And if you enjoyed this one, you'll probably enjoy the next ones I'm gonna post as well. Again, don't forget to check out my links that are gonna be in the description, especially my website, which is gonna contain a text-based version of this tutorial so that you can later on reference if you ever need to. Again, thank you so much for watching this video, and I see you guys next time.